My name is Roger Gibbs. I'm the R from PDR. Started PDR back in '85, and I'm here to show you the workings of our top-selling system, which is the PDR IR-E3 series, and to show a removal and a replacement of, in this case, a BGA, and show you how easy and flexible this system is. Okay, we're just going to show a removal of a BGA. It's of course the same principle for a CSP or for any SMD. Okay, so first we're going to put the PCB, we move the lens out of the way like that. We put the PCB inside the PCB holder like this, okay, spring loaded. We can use the pickup to line up the component exactly in the right place like this, okay. We can bring the IR in here like this, and now adjust the IR. So you can see how you can adjust the IR spot for different size components, very easy to do, and cover the component like this. There's also on this software, there's a control of the vacuum as well. Okay, the system is now set, and we go on to remove a BGA. So to start with, put a little bit of liquid flux underneath the component like this. Not much, just a little bit. It helps with reflow. So start the process like this, hit the start button, and the system now is underway. So the IR will heat from underneath, sensor looking at it, the PCB, you've got IR heating from the top. You can see it's climbing up the line. It will maintain a desired ramp rate and simply climb up the line. It's auto profiling, so it's adjusting itself up and down to climb up the line right. Right, we are now reaching about 127, 128, 130 from the top, and at about 130 is where flux starts to activate. So you want to have a decent slow ramp rate between 130 and about 170 to get the full activation of the flux. And you can see the flux starting to burn off now, which, as I said, it starts to do that about 130. You can see at the monitor there's no reflow, obviously we're not hot enough yet, but you can see the flux boiling off. But it will be acting and it will be doing its job. PCB and component now at 195 or so, and reaching the desired set point. So now PCB has switched off because we wanted a 195 control temp. We're looking for about 245 on the component, so the component is now heating up to reflow. Okay, we are now reaching 245. I turn the vacuum on. We are going into the soak zone, and I remove it, the component, when we're actually inside the soak zone like this. Like that. You can see the lovely solder balls there. You can see how well the component de-wetted and essentially was lifted. That is normally what we see on a PDR. If you look on the monitor, you can see the auxiliary camera and the view we've got, and how nice those, that's a very, very good reflow cycle. If you look at the software now, this is the profile that we did. The logging of what just happened is here. And if you look at the plot, you can see where it all climbed up and climbed up. And here's where we reach reflow, 248, 245 there, which is our desired temp. And we were at 193 on a setting of about 195. And at this point, this is where we see where we actually lifted the component. Okay, we're going to show the replacement and soldering of a BGA onto the board. If it's a QFP, if it's a QFN, if it's an LED, any component, the same issues apply. You have to have good soldering to have a decent result. So we have to take care. We either have to apply solder paste or we have to apply flux if you've got good spheres on the BGA, for example. Dealing now with this BGA, we have two choices. We can apply some solder paste using component print frame, which is often very difficult to use, but nevertheless does put solder paste on the spheres, and then you would turn it upside down and align it and place it, and then you've got solder paste in the right place. But on this trial, what we're going to do is actually going to deal with just applying flux. So to apply flux, I've got two choices. I can either put it on, apply some flux onto a board, and then I can blade it off. For example, I can with a brush make sure it's covers all the spheres, and then with a stencil, with a squeegee, I can totally blade it off. You need about 0.1 millimeter thickness maximum, otherwise you'll have too much flux. Or the other alternative is to put flux in a dip tray like this, making sure that there's the correct flux in there, and then with the pickup lower it into the dip tray and lift it off, and then you will have the correct amount of solder paste or flux actually on the spheres. And that's what we're going to do on this job. Right, to apply flux on with the dip tray, what we do is put flux in the dip tray like this, probably a bit more, and with the squeegee make sure that it's the right depth everywhere. So like this. Okay, get rid of the excess like this and like this. Okay. Okay. It's a little bit fiddly, but it's pretty good. Right, so put this now on the machine. So in the nest I put this on, I'm going to lower the component into it and then apply flux to the spheres. Okay, we now need to lower the component into the flux like this and raise it up, and you can see there's an even pattern there of flux which has now been deposited on the bottom of all the spheres. So to line and place, now what we need to do is take him out of the way, bring him in like this, and then move in the BGA alignment system like this. To align, first thing you have to do is focus on the PCB, which is this, and zoom in as required. I'm zoomed out at the moment, but I can see it, and then lower the component into focus, which is like that. Okay, and what I do is I basically set this ball here 50% out, in the middle there 50%, and you can see the rotation is wrong. So the first thing you do is sort the rotation out. So rotation, get that correct like this, that's all okay, and then do again, get it 50% out, it's like this. Check my rotation, that's okay, that's some very good rotation. And then you do your X like this, get it in the middle, and you do your Y like this. Check top left, top right, all sorted. If you want to, you can check bottom left, bottom right, all sorted. If you want to, I'll show you, you can zoom right in like this, and you can see the spheres like this. Okay, so it's a very good image, all correct, and that's it. Okay, component is now lined up with the PCB, so we take the prism out of the way like this, and then we go and place like this, and it touches down. You see there's LED lights up to show that we've actually reached the right place. So kill the vacuum like that. Okay, take the pickup out of the way like this. Now bring in the IR like this, And quite frankly, we just start the operation. Okay, we've aligned, we've placed, everything's ready to go. We now just start the same reflow cycle that we used for removal. So I hit the start button like this. And on this occasion, we just do nothing more, just let the system do its full profile. You can see it climbing. And then in this screen, you'll be able to see the reflow when it all happens. The point about the system, it is very easy to use. Essentially you have to have it set up correctly, but it's easy to use. And the point of this video is really to show you that it takes minutes to learn how to use the system. The profiling is automatic, and the aligning and placing is very simple. The point about PDR systems is, although we've got things like automatic pickups and things like this in development and things like this, we have to remember that often for rework you need a flexible manufacturing system. You need a flexible tool which you can one board do this component, next board do another component, and very, very quickly change from one application to another. And this system does that. You can see now we're climbing up the profile. We're reaching about 115 on the component. We'll see in about another 10 degrees higher, we'll see the flux start to activate, and you'll see it on the screen as well. But this procedure is the same for micro BGA, for CSP, for O201s, for LED, the whole thing. It's the same for QFPs in the old days when we used to do those. And the system is very, very flexible on all these different components. And really, probably you would end up with 4 or 5 profiles for just about all your applications. Very, very flexible. We're climbing through 170 now, I can see. We will see flux starting to, this is gel flux, so it activates slightly differently to the liquid flux, but it'll be doing its job now. And as we climb up, we're nearly 200 or so, 190 on a PCB. You can already see the got a target temperature about 245, but probably for this application you'll see it start to reflow below that, probably about 230 it'll start to reflow. It's 225, 226, 230, and we're starting now. Some of the balls have gone. We've reached 245, and now we're in the soak zone where all the bonds are properly formed. And we reach after the end of the soak zone, the system switches off and then starts to cool down. And now it's cooling down, and that will reach the end of the go towards the end of the profile. As we said earlier, if the system was set up with cooling, then at this point the cooling would kick in and cool the whole thing down. You have a run screen, you have a logging screen, so each result is logged and recorded, and a report is generated. You can either generate a PDF or a spreadsheet report where all the data that you need for QA analysis is recorded and with a serial number and all that type of stuff. The system has now reached the end of its profile. I've showed you essentially how easy the system is to use and how easy it controls itself. And that basically is how we solder and desolder BGAs and SMDs on a PDR IR-E3 rework system. Thank you.